Good morning, good afternoon, good evening. Welcome to yet another blog in the EKS Anywhere Saga series. And this time we are fortunate to have Simon Stevens, who's a senior principal engineering technologist within our Geos organization in Dell. While I'll let the intros roll in, this blog today will focus on the practicalities of how do we integrate EKS Anywhere with our flagship platform, which is called as Dell PowerFlex. And Simon is there to talk all about that. But in the few parts and series that we will be now demonstrating, you will see the capabilities of Dell PowerFlex, and specifically with regards to EKS Anywhere and the workload mobilities and the workload scenarios that we can establish through. With that, I also have my colleague Madhvi. Madhvi and myself, we are a part of customer-centric cloud and containers team within Dell, here to advocate various solutions that we have for you. Anyway, Simon, lucky to have you with us. A quick intro would really help.
Yeah, thank you very much, Amber and Madhvi. Good morning, good afternoon, everyone. Simon Stevens. I work in the Dell Geos team, so I'm an engineering technologist who looks after PowerFlex. It's been my delight to work with the product ever since EMC purchased Scalo some 10 years ago, and it's interesting that this product has really evolved and seen lots of evolution as part of the Dell portfolio over the last 10 years. And obviously today I'm here to hopefully give a quick introduction as to what exactly is PowerFlex if you've never ever heard of it before.
Sure. Madhvi, a quick introduction from you again would help.
Hi everyone, I'm Madhvi, part of C14. I'm in the APJ, and my interest with PowerFlex started off with Apex block storage, and eager to learn more. Thanks.
Thanks. So Simon, we definitely in this introduction video, we would like to hear from you your top of mind and perspective of why PowerFlex and why is it so meaningful for our enterprises today?
Fabulous. Thank you very much, Amber. So what I'm going to do this morning is actually just have a quick conversation around the basics of what exactly is PowerFlex. Let's just get the PowerPoint working. What we typically find with PowerFlex and why customers are using it is that in today's data centers, infrastructure, both on-prem and public cloud, customers are looking for solutions that give them, simplicity and the ability to solve multiple problems using as few products as possible, and especially when it comes to infrastructure. Now, over the last sort of 5 to 10 years, we've seen the rise of hyper-converged infrastructure coming from out of nowhere and replacing the traditional 3-layer SAN infrastructures that certainly were prevalent in data centers from the start of the century. But when we talk about PowerFlex, what is it? It's actually taking the benefits of hyperconverged infrastructure, i.e. having scale-out node-based x86 architecture, the simplicity of automated lifecycle management to manage things easily, and the super simple button for ops teams, and simplified operations, but also adding on top of that 3 additional differentiated benefits. And the first one with PowerFlex was that from the word go, it had an architecture that was created to enable the scaling of compute and storage independently of each other, which really was key, especially in the early days of hyperconverged infrastructure, where typically if customers rolled out and deployed HCI platforms, they had to scale up storage and compute together, which led to unused resources, especially if you had compute-intensive environments. For example, Kubernetes, where typically persistent storage in the early days was pretty small footprint. Yet it was the compute that you needed to expand repeatedly. It ended up with those HCI platforms. Just you'd add in these predefined nodes that had compute and storage, and you had a load of unused storage, and that's obviously inefficient and costly for our customers. At PowerFlex, you've always been able to independently scale those 2 components together. Secondly, PowerFlex has always been able to be truly heterogeneous. By that I mean it doesn't matter if you're running virtual workloads, bare metal workloads, container platform of your choice, You can run all of those different solutions in the same system, in one single cluster, which gives, maximum consolidation. And it also means that you're getting rid of that problem of different silos of storage. In the old days, you typically have, one SAN for VDI, another SAN for general purpose workloads, third SAN, or, specialist Snowflake for something like, Oracle Exadata. And the more of those islands and those silos you had, there's more complexity, more management overhead, and again, back to that stranded, unused silos of resource that sat there doing nothing simply because, you have all that spare capacity, but the other applications can use that. When you've got a truly consolidated infrastructure platform like PowerFlex, that stranded resource problem goes out the window. And finally, the unique differentiation of PowerFlex's blinding performance. We have performance in spades not only to deal with the most complicated, complex, aggressive workloads, but also when things go wrong, when nodes fail, when disks fail, we still have that performance on the back end to enable quick, instantaneous rebuilds without affecting the workloads themselves. So you can have disks fail in the background, but your actual operations team and the applications won't notice there's a problem at the back end because PowerFlex is dealing with that behind the scenes without applications missing a beat. And that is really transformation in enterprise environments, because if you're running SQL Server Oracle workloads and they're able to withstand failure, it means that the application can run seamlessly. And especially when we talk about putting this platform into public cloud, where clearly availability of components and availability zones, that sort of thing, is a key differentiator between on-cloud, on-prem and cloud environments. And secondly, if you're trying to run, the most performance demanding application or workload, typically in the public cloud, SLAs tend to get breached. But if you can run those really demanding applications on the public cloud and provide, sub-millisecond latency, that suddenly opens up a whole new world of what applications can be pushed out into the public cloud as opposed to running on-prem. So far, so good, Amber?
Yeah, I think it makes a lot of sense, especially, if I was to look into the recent trends, right? Especially with the data on Kubernetes becoming mainstream, right? We've all seen how companies are now adopting, Kubernetes as the mainstream, infrastructure provider, not only for traditional, or I would not say traditional, but the microservices or containerized applications in a very legacy sense, but also now running demanding workloads on Kubernetes with persistence. And on this slide, if I was to summarize or interpret in my words, what you're saying is basically PowerFlex is not only a HCI, it's also equipped to provide a world of opportunities from a storage perspective, or as a software-defined storage. Am I correct in saying that?
You are absolutely correct, Amber, and that dovetails really nicely onto the next slide that's going to really show that software-defined capability, and especially how it helps in Kubernetes and those software-driven API worlds that customers are moving to now. Because to your point, PowerFlex's key architecture differences, we have three really clever pieces of software. These are software that's been around and developed now for over 10 years, so lots of time spent developing these, and we know that this componentry works. And basically the three pieces of software are, we have an SDS, a storage data server, which we want to install on any x86 server that we want to turn into a storage node. We have the SDC, which is our client that we can install on any compute node that we want to run applications on and consume the storage. We can install both of those components together onto a node to create a truly hyper-converged node if we so desire. And we also have a piece of software called the MDM, Metadata Manager. That's effectively the brains of the software of PowerFlex. We have to install that on the first 3 to 5 nodes to form a cluster. But other than that, once it's installed, we effectively forget about the MDM componentry itself. So you take those basic 3 software components and you go, right, I want to create, my Kubernetes infrastructure. on-prem, what do I need? Well, first of all, we need storage nodes. So obviously take a 1U or 2U server that's full of storage disks, SSD media, and NVMe media. We don't care. Obviously, we can't create a cluster storage platform with just one node. We need several nodes, because we need to meet the capacity requirements, and B, we need additional nodes to ensure that we have availability if the node fails, if the disk fails. So with PowerFlex, minimum that we tend to recommend are 4 nodes. We install our SDS, the storage data server software, onto each of those nodes, create a cluster, and even with a 4-node cluster, we have that software-defined storage array that can provision hundreds of thousands of IOPS of low latency, high bandwidth storage, gives 6 to 7 nines availability. Because we're written software-defined from the word go, we've always had rich API capabilities, and we actually have an amazing proposition insofar as we can start small, 4 nodes, and scale up to 512 node clusters, 16 petabytes usable storage within a single PowerFlex cluster. And with that storage system created, we can create storage infrastructure that can run practically any workload that customers are wanting to run in today's data center. But the key thing here is look at the numbers themselves are quite impressive. But look how small a footprint, 10 million Oracle transactions in 5 rack U of space, 7 million SQL Server transactions in 8 rack U. You can create transformational storage footprint here with really small amounts of data center footprint with PowerFlex. So the storage is one half of it. Obviously, we need to be able to consume the storage platform, and what we do is that we install the SDC onto whatever applications server we want to run. Now, clearly for Kubernetes, we have to have the SDCs for the Linux operating system that's underneath the Kubernetes distribution. But the key point here is that it doesn't matter which operating system hypervisor Kubernetes platform customers are running, we will always have a client for all of those platforms. We just install the client that's relevant for whatever the customer's running in their data center. And that also means that we can create, compute nodes that meet the customer's requirement. If they need to have GPUs thrown in them, not a problem. We can optimize the compute based on the customer's workload requirements. To connect it all together, well, we need IP switches between the two. PowerFlex has its own proprietary protocol that works over native IP, so it doesn't matter what IP switches customers have. Cisco, Dell, Juniper, it doesn't matter. We'll connect and work with them quite happily. Once we've connected all of the storage nodes to the compute nodes, then it's a case of just mapping up storage to that compute node, just like you would with a traditional fiber channel SAN, where you'd have to do a bit of lump masking to an HVA on a node. If customers are running third-party hardware, it's not a problem. We just get the SDC for that platform, install it on the x86 server, sewn in the software, and off you go. And then finally, obviously we have the lifecycle management stack, PowerFlex Manager, which does all the automation, the deployment, the upgrade, the patching. And here's the key thing, all of this is software. So we've been running this on-prem quite happily for a number of years. It's very simple to just take these components and install them out on the public cloud to the customer's choice.
I think that's a fantastic, overview, Simon. I really like the part where you mentioned that this is a software-defined play from the word get-go, and this has been instrumented as a software-defined play from its inception. Although what we see is a deployment of this on a Dell stack. In the multi-cloud era, like we see as of today, this software-defined play is also available on AWS and on Azure and other hyperscalers to follow, right? And I think interestingly, what we see on this slide is the presence of SDCs, which, like you said, are clients which are talking to the software-defined servers there, the storage servers, through standards, which are native to IP connectivity, right? Interestingly, in this blog, what we will be, or in the advent of exploring features with PowerFlex. We will also be installing SDCs for EKS Anywhere on a Ubuntu host-based system, right? And that's something that you won't generally see as a publicly documented, routine or procedure. So I think it's going to be very interesting of how do we actually make sure that the picture is complete, so that no matter what your workload is, virtualized, bare metal, which has always been the play, but now in the cloud native era, containers prominently using persistent storage through the CSI modules, will get greatly benefited from the scale and the possibilities that PowerFlex can bring to the table. And we'll talk more in the upcoming videos actually. With that, I would say thanks, Simon, for helping us glance through this powerful and potent platform. That's it.
Very welcome, Lambert.
Thanks a lot.
Thank you very much, everyone.
Thank you.